Can you explain to me what in the loop is in terms of hardware or software in the loop testing?
So hardware in the loop or software in the loop testing is when you actually replace part of a process with a piece of hardware in the test environment or even software. It allows you to replicate a full environment effectively, but without needing the physical test assets. So hardware in the loop obviously has a piece of hardware in that system, but that hardware may be one component or a number of components that simulate your test environment into thinking it's the real part effectively. So it's a very good way to simplify a system, and it allows you to, for example, your simple controller can sit in the loop, in the control loop, thinking that it's connected to a multi-million-pound machine, but in fact it's connected to a bunch of inputs and outputs that are simulating that machine. So that allows far, again, better iteration and better testing, and edge cases as well, of course, where you can inject faults into various items and parts and see how your control system handles that.
So how are you measuring better? Accuracy, reliability,
And
speed?
speed of getting the answer and the speed of data effectively. Uh, you often you have these systems can operate autonomously, and you set them up, overnight or a period of days, and they go through a number of tests and produce a report of any failure states that may have occurred effectively. So that really helps to, rather than have an engineer sitting there performing a set of tests with the limitation of their attention span, I think, for use of a better word. It does allow you to operate these things repeatedly and consistently. Obviously, though, the caveat there is if you have a poor model, you're going to repeat the error that you've made from that model multiple times. And that's why in the loop testing is part of a testing program and a validation phase. It isn't instead of. You still need to actually have abuse testing and edge case testing, and you need to have some very talented people that can understand what the typical failure modes are and can inject those problems and those faults.
So this sounds ideal for businesses and sectors in particular that have a very long lead time between when they start a design of a new asset. Let's say it's defence and it's a new asset for defence, and actually rolling the first ones out in production. Now, I would imagine that squeezes that time through the design and development stage. Is that right?
Yes, it's the same case as previous, whereby often many people will be doing this to some extent. Everybody simulates. People produce a spreadsheet with a very basic model and a mathematical formula, and to get some idea as to what feels right. If this goes up, does this go down, and so forth. However, it's as you get into more mature models where the elegance really comes in, and of course there's the initial kind of impact and the benefit you can get, which again that top level Excel spreadsheet may give you in the first instance. But when you actually get to the real tuning of a model, and in fairness, these days there's an awful lot of incredibly talented, some talented engineers and some very good technology in the world. A lot of effort and thought has gone into it, and therefore the gains that you're trying to achieve are quite small. They're quite marginal. So long gone are the days in Formula One. Take that example where someone's 2 seconds a lap faster than somebody else because they've engineered something better. You're really fighting for milliseconds now, and this is where you need to get that level of maturity and complexity within some of your models and some of your testing validation and your design loops effectively and testing loops to really get to that level of the milliseconds in the Formula One language. So it's interesting because these are things that people have been doing, but the difference of doing it well is starting to make a real difference now.